Okay, so we're on the back side of your 6.2 notes. That theorem 6.7, I kind of rushed through it the other day. What this one tells us, and it talks about 3 parallel lines, but it's actually 3 or more parallel lines. Okay, so if we have 3 or more parallel lines, and if they cut segments from a transversal that are congruent. So what they're dealing with here, if I look real close, they are saying that we have these parallel lines, on that blue. This line is parallel to this line and parallel to this line. Those 3 lines happen to cut this transversal into 2 congruent segments. This segment here, this segment there. Okay, so I have a congruent segment here and a congruent segment there formed by the parallel lines and the transversal. Okay, that's just the setup. Everybody understanding the setup to this theorem? Okay, so if we have that situation, that means any other transversal that I have, so for example this one here, if I have another transversal cutting those same parallel lines, that means I'm going to have, again, congruent segments formed in between. That's what this theorem is telling us. Okay? So that means if I drew in a third transversal, let's say I have a line going right through here, that third transversal is going to be cut into 2, in this case 2, but it could be, depending on the number of parallel lines, congruent segments. This segment is then congruent to this segment. It doesn't matter where I put the transversal, doesn't matter which angle I put the transversal. If you have that initial setup where your parallel lines are cutting one transversal evenly into congruent segments, then every other transversal cut by those same parallel lines will also be cut into congruent segments. All right? That's the setup we're dealing with here. That's what the theorem is telling us for theorem 6-7. Okay? So how does that help us? Well, if we take a look at a problem such as this in our notes, they tell us that we have 4 parallel lines. Okay, we have 4 parallel lines. They're already marked in the diagram parallel. And they tell us that the distance, remember that's what that notation says right here. AB isn't talking about line segment AB. It says the distance from A to B is 2. And the distance from B to C is 2. And the distance from C to D is 2. So that means each one of those segments are congruent to each other. All right, right there, that's the setup that theorem 6.7 is talking about. We have parallel lines cut by a transversal, and that transversal is cut into evenly spaced or congruent segments. So it says that EF, the distance from E to F, is 2.5. So if E to F is 2.25. If E to F is 2.25, that means, according to our theorem, that this segment is congruent to this segment and congruent to that segment. Because any transversal cutting those 3 parallel lines will be congruent. So we end up with 2.25, 2.25, 2.25, and I want to find the distance from E to H. E is right there, H is right there. So I need to take 2.25 plus 2.25 plus 2.25, or 3 times 2.25, right? And that's going to be E to H, and you're telling me that that is 6.75?
Yep.
Excellent. That is our distance from E to H. Okay? Any questions on that example? So then that example leads into the problems from the homework that we had to deal with that same situation. And so let's take a look at those. So in the homework assignment 18 through 24, we had 4 parallel lines. And so let me quickly recreate the diagram to the best of my ability. So we have 4 parallel lines. And let's see here. We got a couple of different transversals going on. We have one going through something like that. We've got another one going through like that, and we've got a third doing something like that. Okay, we have our parallel lines. And we know some information. We know that this line segment here is 3 units long. We know the line segment up here is 2.25. And let's see, we also know a whole bunch of names for this. Okay, so we have all the names for our different intersection points labeled. Number 18 asks us to find the distance from x to z. Okay, finding the distance from x to z. So first off, let's just find where we're talking about here. We know that x is sitting right here, and z is sitting right there. Now notice what line xz is part of, line segment xz is part of. That is part of this entire transversal here, right? Well, notice that transversal is being cut by our parallel lines running this way. And there's actually one more piece of information from the instructions that I forgot to mark on here. The instructions tell us that PQ is the same length as QR. Let's see here. PQ is the same length as QR, which is going to be the same length as RS, which is hard for me to mark that. So I'll just go like that. Okay? So if those 3 segments are congruent because of my parallel lines, that means any other transversal is also going to be congruent. So if TX is 3 units long, from T to X is 3 units, that means from X to Z must be 3 units, and Z to U must be 3 units. Okay, because you're following along that transversal.
What was the second one you said? You said Z to U, and then before that one you said what?
X to Z.
X to Z.
Yep. Because if you look here, if it's possible for you to kind of ignore the other transversals, when you're looking at this diagram, look at the parallel lines. Okay, look at the parallel lines, and then look at the transversal. And as I'm kind of glancing around to some of you who redrew this, you redrew it improperly. If you look at the diagram in the book, X is the intersection of 3 different lines. It's the intersection of 2 transversals and this one parallel line. Okay, so if you drew this wrong, this problem is going to be very difficult to solve because you're not looking at the proper diagram. Okay? But look at the 4 parallel lines, look at this transversal, you see that TX, XZ, and ZU are the 3 line segments formed between the parallel lines. And so therefore those 3 line segments have to be congruent to each other, making them all 3 units long. Okay? If we take a look at number 20, number 20 is asking us for XV. XV. Well, XV is going this way. And again, XV is part of this whole transversal, meaning that these segments in between our parallel lines must be congruent to each other along that transversal. So XV must be the same length as WY, meaning it's 2.25. Looking at number 22, we want to look for YV. YV starts at point Y and heads down to point V. So that's going to be two of those segments added together. So it's 2.25 plus 2.25, giving us 4.5. Okay, and this is going to be WV. And so again, that's then those three segments added together. Going from point W, clear up here, down to point V, we go through those three congruent segments. And so it's going to be 2.25 plus 2.25 plus 2.25, or 3 times 2.25. I still want to see what you're doing. Yeah, so anytime you're doing these problems, show me what you're doing. It's just part of writing down your work, okay? If you're adding things together, show me what you're adding together. If you're multiplying by something, show me what you're multiplying by. You know, if you can do that in your head, then more power to you. You're still calculating it in your head, but you still got to write down and show me what you're doing. Okay?